Welcome to Best Academic TV. In this video, we're gonna focus on Uniport post-Utme exposed questions on resistivity and conductivity. Resistivity and conductivity. Let's know what resistivity is. Let's know what resistivity is. Please write. Let's take a note here. Resistivity is a property of a material that opposes the flow of electric current. Is a property of a material that opposes the flow of electric current. We can also define resistivity mathematically as the resistance per unit length per unit cross-sectional area of the material. The resistance per unit length per unit cross-sectional area of the material. Before we solve a question here on resistivity and conductivity, let's look into the mathematical definition of resistivity from the statement here that it is defined as the resistance per unit length per unit cross-sectional area. Please take note of that. Per unit length per unit cross-sectional area. And after then we can solve some questions on resistivity. Okay, so mathematically here, resistivity, this can be defined as rho A over L, where this arrow here represents resistance. Please take note of this. There is a difference between resistance and resistivity. Okay, while A is a cross-sectional area and it can also be expressed as pi r square. This arrow here represents resistance. The A is cross-sectional area. All right, and it can also be calculated using pi r square if the area is not given. If radius is given or diameter is given, you can use this to calculate for the area. So the L here represents length of the material. The length of the material. From the formula here, it means that we can easily express the unit of resistivity here. Okay, now how do we express the unit here? The resistance, the unit for resistance is ohms. The unit for area is meter square, and the unit for length is meter. So when you express this, it means that I will have this to be from the formula here. The unit will be ohms meter square over meter. Please take note of this. We are using the formula method to express the unit. This meter will cancel this meter. I'll be left with 1 meter at the top. So if that is so, our unit here will be ohms meter. Please take note. So the unit of resistivity is ohms meter. So the unit of resistivity is ohms meter. Right, now let's look into some questions here on resistivity. But before we look into some questions here, some possible question on resistivity here, let's understand more on the formula. Let's look into the variation of resistance from the formula. Let's look into variation of resistance from the formula. There are some certain questions that you will come across that when the resistance increases, what happens to the length? And when the length increases, what happens to the area? So let's look into the variation of the resistance to length to area and vice versa. The relationship between area to resistance and the relationship between length to resistance. Okay, let's look into this. Let's look into the variation of resistance from the formula. Okay, from the formula here we say that resistivity is equal to rho a over L. So making resistance, if you are looking into the variation of area, it means that if you are looking into the variation of area, it means that we have to make area the subject here. If you are looking into the variation of length, it means that we have to make length the subject here. But our intention here is to look into the variation of resistance. So let's make resistance the subject. When you make resistance the subject, our expression here will be class rho A when the cross multiply will be equal to class rho of L. Please take note. So divide both sides by A to make the resistance the subject. Resistance here will be equal to class rho of L over A. Okay, now this is the formula that relates resistance to that of length, and this is the formula that relates resistance to that of area. Please take note. So let's know the variation here. Of course, this rho here is a constant value. Please take note. The rho is a constant value. This is a constant value. So in mathematics, whenever you introduce constants, it means that I have to remove proportionality to introduce constants, right? I want to remove these constants here to replace proportionality, okay? When you do that, we have something like this. When you remove the constants, that's the resistivity is a constant there. When you remove the constants there, I will have the formula to look like this. That is rho is proportional to, remember, when you remove the constants, you replace proportionality. When you introduce the constants, you remove proportionality. So this will be L over A. So what does it mean here? It means that this resistance here, remember there is difference between resistance and resistivity. What we are treating here is resistance. This resistance here is directly proportional to this length here. So if it is in a direct proportionality, it means that the increase in resistance will cause an increase to the length, and the decrease in the resistance will cause a decrease to the length. So inversely, statement will be the increase in resistance will cause a decrease in area. Okay, now let's get some questions here that applies to this particular formula. Question 1, please. All right, we are giving exam possible questions here. Question 1, they said a wire's resistance is directly proportional to its they said area. If you look into this formula here, if you look into this formula here, from this formula here, class, the resistance is not directly to area. Okay, if you look, diameter is not directly to diameter. Please take note. Since it's not directly to area, that means it's not directly to diameter. Okay, length, you can see that the resistance is directly proportional to length. Okay, so the answer here, without wasting time here, the answer here is C. So let's look into the next one here. Question 2, they said the resistance of a conductor increases when it, okay, so what happened to it? If the resistance increases, what will increase? The length, all right? Because the length is directly proportional to the resistance. So any increase in length will increase resistance, and any increase in resistance will increase length. Please take note. Inverse statement will go with area. Please take note. So it means that the answer here, without wasting time here, the increase in the resistance will cause an increase in the length, which is this here, while the increase in resistance will cause a decrease in the area. Please take note of that. So we are given a question here, question 3. A wire has length 4 meters, area 2 times 10 to the power minus 6 meters squared, and resistivity is given to us as 1.6 times 10 to the power minus 8 ohms meter. We are asked to find the resistance. Okay, solution first. To find resistance, when resistivity is given to us here, the formula to use is resistivity is equal to rho A over L. So our intention here is to replace what is given to us here. Now from the equation here, the resistivity is given to us as 1.6 times 10 raised to the power minus 8 is equal to resistance times the area is given to us as 2 times 10 raised to the power of minus 6 over the length is given to us as 4. Remember, our intention here is to make arrow the subject of formula. So let's cross multiply here. When you do that, this will be arrow times 2 times 10 raised to the power of minus 6 is equal to class 4 times 1.6 times 10 raised to the power of minus 8. So divide both sides by what is attached to arrow here, which is said to be 2 times 10 to the power minus 6. So our arrow here will be equal to class 4 times 1.6 times 10 raised to the power of minus 8 over 2 times 10 raised to the power of minus 6. So let's punch our calculator. 4 times, whenever you have something like this, the first thing to do is to multiply the number to number and simplify the terms. That is this 10 raised to the power minus 8 and 10 raised to the power minus 6 separately, okay? So let's multiply the number. 4 times 1.8, sorry, 4 times 1.6 will give us 6.4 times 10 raised to the power of minus 8. That is this minus 8 here over 2 times 10 raised to the power of minus 6. So let's simplify this to get the final answer. We'll have this to be resistance to be equal to class, we have it to be 6.4 times 10 raised to the power of minus 8 divide by 2 times 10 raised to the power of minus 6. So class, let's divide. 6.4 divided by 2. At this point, we divide number to number. Okay, our concern here is for number, and later we simplify the terms, that is this and this. All right, so 6.4 divided by 2 will give us 3.2 times 10 raised to the power of minus 8. Class, I want to take from the law of indices, this is term, you take only one, raised to the power minus 8 here. So I want to take this power here from denominator to numerator. The sign will change to plus 6. Whenever you are taking any power from denominator to numerator, the sign will change. Please take note of that. So I will have my final answer here to be resistance to be equal to class 3.2 times 10 raised to the power minus 8 plus 6 will give us minus 2. So changing this to a number, this will be 0.032 in ohms. Please take note of this. This is our answer. So in our next video, we'll focus on the possible questions on conductivity. All you have to do to get the full video is to hit the subscribe button. Okay, thank you.